Okay, in this video we'll be looking at circle theorems, and I have a question there that we need to handle. But before we handle that question, maybe these are some of the things you need to understand, or these are the main properties that you need to get before you could handle any question under circle theorems. Okay, and I'll be giving some useful properties that you need to know before you start handling any question. First, or the first property is that angles in a circle are always 90 degrees. Okay? Or angles in a circle are always 90 degrees, or they are at right angle. For example, I can give an example here. Don't mind the drawings. So when you have a semicircle, or when you have the diameter, remember the semicircle, we know it is a semicircle when it has a diameter. So we can say AB is a diameter, okay? Whenever AB is a diameter, it means this angle here is 90 degrees. That is what we meant with that. And that angle can appear in different forms. We can have another one like that. It can be on the lower side, the circle, still 90, or you can have several such angles so long as you know it is a diameter. This is 90, this is also 90. So long as you know it is diameter. Okay, that is the first point. Then the second point you also need to know is that angles between a tangent and a radius, angles between, or the angle, not angles, the angle between a tangent and a radius is 90 degrees. So whenever, first of all, a tangent is a line that touches the circumference or the arc of a circle at only one particular point. So like we have that one is a tangent. And a radius we know moves from the center. That is 90 degrees. Okay? And we can have it in different positions, or the tangent can be in different positions like that. So long as it's the radius, irrespective of how it appears, the angle between a tangent and a radius is 90 degrees. Okay? Then the third point you also need to know is that angle at the center of a circle, at the center of a circle, is always twice the angle at the circumference. At the circumference. Yeah? This is very crucial, very important. You need to master this. That being our center, so the angle at the center here, this angle here, okay, it's always twice the angle at the circumference. If this is x, that means this is 2x, okay? And the same thing, it can appear in different shapes. You can have that. If this is y, this will be, oh, sorry. Not, let me just use, if this is y, and this is 2y, okay? And we can also have another one, which is that this one, if this is maybe p, this angle here will be 2. The same property applies for all that. The next point, or the next useful property you also need to know, is that angles in same segment are the same. Same segment are same. And this is one of the very simplest property. They are the same. Because whenever you have a circle and you have something like that, this is P, this will also be P. If this is Q, that is also Q. But take note that property doesn't apply for a case like this. Sorry, the drawing wasn't as expected, so let me just redraw it properly. Okay, so we have the circle there. We might have some cases like a question like maybe something like that. Okay, at this point, and this can't be. In this case, this is not true. So in this point, I would say this does not apply to that kind of question. Okay, then the fifth point you need to know, this is now when you're dealing with cyclic quadrilaterals, and I believe you know what cyclic quadrilaterals are. Opposite angles in a cyclic quad adds up to 180 degrees. Okay, opposite angles in a cyclic quadrilateral. When we talk of a cyclic quadrilateral, we know quadrilateral is a four-sided figure, but for it to qualify to be a cyclic quadrilateral, its edges must touch the circumference of that circle, such that if this is A and this is B, then we mean A plus B is 180 degrees. The following is false or does not apply the same property. When you look at a question like this one does not apply the same property. Reason being, all the corners of that quadrilateral are not touching the circumference of that circle. And this is the last property you need to know, that angle between a chord and tangent is same to an angle in an alternate segment. Okay, so when we talk of the alternate segment, this is what we mean when, so that is the circle. You can have the tangent, oops, so that is the tangent. So this tangent from this point, if we have a chord there, that chord can make a triangle. That, so what we mean is that this angle here is the same as this. Equally, this angle here is the same as that. So if this is P, this is P. That means if the other angle, this was Q, this is also Q. So these are the 6 main properties you need to know for you to be able to handle any question dealing with circle theorems. Okay? Hope you are good. Let's now go back to our question that we've just written, or that is up here. Okay? This is the question. And this being the question, this is what I usually prefer. When you have such a question, the first thing you can do, try to fill the angles within that question or within that circle or within that diagram you've been given before even going to the questions. Okay, so for example, we can use several properties. Like at this point, this is angle 60 degrees, and looking at it, this is a chord, PQ is a chord, and CB is a tangent. So already there's a property ringing on my head when we talk of the chord, tangent, and an alternate segment. So if this is 60 degrees already, as you can see here, it means the angle at S there will be 60 degrees. Okay? That being 60, I can easily get this PSQ, in the triangle PSQ, I can easily get angle PQS because this is a triangle. Okay, so and we know angles in a triangle add up to 180. So basically, I'll have 180 minus 40 plus 60. So that is 180 minus 100, which will give me 80 degrees. So the angle here is 80 degrees. Okay. Having said that, looking at the angle at this particular point, that is the angle BPQ. The angle BPQ is alternate to PSQ. So this angle here, let me use a different mark. This angle and these are the same based on the idea or the concept of alternate segment, chord, and tangent. If that is 60, automatically I can get this as also a 60 degrees, because 60, 60, this gives me 60. Okay. Then we move on to the next angle that you can easily get, the angle SRQ. This angle here, we can easily get it because looking at the shape SPQR, that is a cyclic quadrilateral. It being a cyclic quad, and we just said opposite angles in a cyclic quad add up to 180. So it means this and this adds up to 180. So if that is the case, then it means to get this angle here, I'll easily take 180 minus 40 degrees to give me 140 degrees. So this angle is 140 degrees. Okay. Having done that, I think we've covered pretty much what is in that shape. So we can try now answering the questions that we have there. Like the first one, QSP. QSP. Already we have it, 60 degrees. Okay. Move to the next one. PBQ. We already got it, 60 degrees. We move to the next one, angle SQP. As you can see, it is 80 degrees. And then the last one is angle QRRS, which is from here 140 degrees. Okay, that is it. Therefore, you can use the following properties that we've just highlighted, or the properties that we've given down here, to help you handle any question on circle theorems. Okay, thank you so much.